and welcome everyone to Summary Shorts. And in this lecture, we are going to talk about three very important subgroup structures. Okay, namely, we are going to talk about what are normal subgroups, what are centers, what are centralizers, and what are normalizers. So let's get started. So suppose G is a group, we say that N is a normal subgroup. So this is the notation we use for normal subgroups. So we say N is a normal subgroup if and only if for every element G in G, G and G inverse must exactly be equal to N. Okay. So this condition if satisfies, we say that the subgroup N is a normal subgroup in G. And normal subgroup is extremely important because to define the quotient group we require N to be normal for the subgroup to be well defined. The center of the subgroup is actually the collection of all those elements which commutes with every other element for all A in G, right. So the center consists of all those elements which commutes with every other element of G. Now given a set or rather a subset of G, you can take any subset. So this is a subset. We define the centralizer of A in G to be the collection of all those elements G in capital G, that is the elements of the group, such that GA is same as AG for all A in A. What do I mean by this? That is, the elements of the centralizer, they commute with every element of A and nothing else. Is it clear? And finally, we come to the notion of a normalizer of a subset A in G, which is the collection of all those elements G in capital G, such that G capital A equal to A capital G. That is, they commute as the set A. What do I mean by that? Let me typically explain it in very short. So GA consists of all the elements of the form GA for all A in capital A, and AG, it consists of all the elements of the form AG for all A in capital A. So clearly GA equal to AG, this implies that G times A, where A is some element in capital A, must be equals to A1 times G for some element in capital A. Therefore, they need not commute with every element in A, but rather they commute as a whole set. So you need to be very sure about this. Otherwise, you would ask that why is the normalizer different from the centralizer, and this is the reason why. So they are not the same. Rather, you can try, and this can be thought of an exercise, that try and check whether what is the inclusions between centers, centralizers and normalizers. Thank you.